Hi guys, good afternoon. So in the last session, we started with the routing and you're going with the subnetting part, IP and subnetting. I asked you guys to revise. I believe all of you have revised. Now all good? Any doubts? No? Okay, just waiting for the trick. But first, let me check. Let's say, hmm? Okay. Try again. 208 is network ID. Okay. Anybody else? Hmm? 240. No. Hmm. 210. Hmm. 20. How many of you actually revised the subnetting session? One, two, three, four. Honestly, answers? Do not broadcast. If block size is 16, 220. 220. This is the answer. How many of you got the answer? One, two, three, four, five. What about other people? Okay, one more. Very simple. This should be very easy. One or two is? Huh? Mhm. Give me the complete address. Hmm. Hmm. 52. Hmm. Not one, not four. Yes. 252. Something 253 you said. Everybody got the answer? Clear or doubt? How many of you have doubt in this? Hmm? Doubt? No doubt? Clear? Yes. And what about the person in between? Next. Clear? No. Okay, try this. Hmm? Hmm? Broadcast? Clear? No. How many of you have confusion in the or doubt in the submitting? 1, 2, 3, 4, 5, 6. Okay. This is the answer, right? Okay. See, any any kind of question can be there. Let's say this is the question. First thing, so first thing you're supposed to do here is three steps. Okay. Find the interesting object. Now, what is an interesting object? Simply understand any object, any object that contains both network as well as host space. Okay. Any object that contains both network as well as host space. Right. So if I write it in binary, this is more than 24. That means definitely the fourth octet. The fourth octet contains, because 8 plus 8 plus 8, 24 already there. So fourth octet has both network bits as well as host bits. If still confused in this also, you can write down this thing in the binary, right? This 29, if you write in binary, we know that 24, 25, 26, 27, 28, and 29. 5 bits are already there, 1, 2, and 3. So which octet contains both network and host? Fourth octet. So fourth octet becomes our interesting octet. Okay. So we know which octet is the interesting octet? Fourth octet. This is one thing done. Second thing we have to do, find out the block size. Find out the block size. This is the second step. Block size of interesting octet only. We don't care how many network bits or host bits are there in any other octet. We just focus on which octet? Interesting octet only. So right now, which octet is the interesting octet? Fourth octet. How many host bits are there? 3, right? So how do you calculate the block size? 2 per number of host bits. And since we are talking about interesting octet, interesting octet. Yeah. This will be what? 2 per 3, which is 8. This is our block size. Correct? Now, there are few methods you can use, like you can start your fourth octet. We are focusing only on the interesting octet. Other octets we don't care about. Okay. So either you can start like this, like first is 0. The minimum value can be 0. That is my first network ID. After that, next network ID will be what? I will keep on adding my block size. 8, then 16, then somewhere it will be 10 times is 80, 20 times is 160, 30 times will be, if I go 30 times, it will be 240. Before 240, if I try before 240, 232, right? This is my network ID, correct? Okay. Now, if I take a look at the value, what is the value in my interesting octet? It is more than this, less than this. This is my network ID. Next network ID is starting at 240. So that means this will end at. You got the answer. Just the interesting octet value you have to focus. This is one way. Another way is you have your block size. You have your block size. And what is the value here in the interesting octet? 234. Divide it with your block size. Find out the complete division, nearest complete division. Around 234, what are the numbers which are complete division? Okay. If it is less, okay, it is network ID. If it is less than this number or equal, okay, if it is less or equal, that is your network ID, the nearest. Let's say, for example, if I try to divide 234 by 8, I see 8 3 is 24. That goes higher. If I try to divide 8 2 is 16, right? So if I go with this, how should I do that? Just give me a moment. I'll explain it. We'll do it old school way. Okay. Okay. So I need to divide 234, right, by 8. So 8 2 is 16, right? How many times? 7, 4. Now 8 8 is 64, 8 9 is 72. So this is the number. It has to be 2 for complete division. So if this one has to be 2, that means this one also has to be 2. Yes or no? So that means this is my network ID. Nearest complete division will be 232. Getting it? So this is my network ID, 232. 232 is my network ID. Clear? Yes or no? Or else, if this is also confusing, $72. What is the remainder? 2. Just 234, your number minus your remainder gives your network ID. Clear? So in my fourth octet, if the value is 232, that is my network ID. And next network ID, I will add 8. So next network ID will be 240. That means this will end at 239. Clear? One more example, let's see. We'll make it more clear. Okay. This is one example. Is it clear? Okay. Now, another example. Let's take example of, for example, this question. Okay. If we take example of this question here. Okay. So here I have 101, 102, 103.104/23. Now 23 means what? Interesting octet will be third octet, less than 24, third octet. Okay, so that means in third octet, okay, we get to know third octet is our interesting octet, right? How many host bits in the third octet? Everybody agrees? 1. 2 raised to power 1. 2. My block size is what? 2. So my third octet value, I'll divide with 2 and I'll try to find out the value which is nearest complete division. So what do you think? What value will be there? 2 5s are 10. And if this is 2, that will be complete division one time. Like if I multiply 51 times 2, it is 102. This is my nearest complete division. And next will be 104. So that means starting from 102, ending at 103. Getting it? Starting at 102, ending at 103. And fourth octet, it was host bit. And host always start from minimum 0, maximum 5. Clear? Yes or no? One more example. Take example of this one. Now this one is /28. Which octet is interesting octet? Fourth octet. How many host bits? 4. 2 raised to power 4 is 16. Fourth octet value is what? 222. Divide. 222 divide by 16. So again try to divide same old school way. 16. So 16 1 is 16. This is 6. This is 2. Right? Now 16 3 is 48. How much? Subtract. This is 4. 14. 222 minus 14. Network ID. This is 20. Your network ID. And if you add your block size in this, that will be next network ID. That will be next network ID, which is, I think, 224. So that means if next network ID is 224, this will end at 223. Understood? Yes or no? So all you need to do, whatever the number you get, just find one nearest complete division before and after. That will give you entire range of IP address. Yes or no? This example. /5. Which octet? First octet is the interesting octet. How many bits? Host bit is 3. 2 raised to power 3. 8. Now 10. What will be the nearest complete division? 8 only. 8 is the nearest complete division. And next complete division is 16. So that means 8 to 15 is my range. 8 will be my network ID. And 15 will be my broadcast address. Now, remaining 3 octets, they are completely host. So that means they will start from minimum and will go till maximum. This is how you get the answer. Is it clear? Guys, clear or not? Or still there?
Yes.
Shall we try again? One more time? Okay. Let's say try this one. Hmm. Yeah, 20 again. Mhm. You have the answer? Easy enough now. So there is nothing to worry about, what is the IP address given, what is the CIDR given. Okay. If you focus only on the CIDR and you make your calculations right, everything is good. You get the correct answer. Okay. Online people clear?
39.255. Yeah.
Okay. Oh, sorry. Hmm. And uh, class 19. Which octet is the interesting octet? Third octet.
Third octet.
Now in third octet, how many host bits? 5 host bits. 2 raised to power 5. 32. Divide 196 by 32. How many times? Hmm? 6 times? 6 times will be 192.
I mean 192.
You already get the number. Now subtract. Like what is 4? So 196 minus 4. This is your network ID. 192. Add 32 again, your block size. So you will get the next network ID, which is 2 to 4. So minus 1 is your broadcast. Okay. If your first network ID is this, next network ID is this. That means this network is ending where? 2 to 3 only. Clear?
Yes.
Clear to everyone? Okay.
223.2. Yeah.
This is the network ID. This is the broadcast office. Right? Okay. So I believe subnetting is clear to everyone now. Okay. Next thing we will discuss is about an important protocol for communication, which is address resolution protocol. So what is ARP? Hmm? To find the MAC address for the IP address. Okay. What is this protocol? Why this is used? That's it. Hmm? How do you explain ARP? IP to MAC mapping. Okay. Anybody else? In the interview, if you'll answer like this, do you think interviewer will be happy? Hmm? So how you'll answer? Let's say they ask you what is ARP or explain ARP. How you are going to explain it? Hmm? How you are going to explain? Nobody. Try it at least. Everybody has the answer in mind. Nobody dares to speak. Huh? Try. Right or wrong, I'll correct. In interview, you cannot sit like this, right? You have to speak. Try at least. Good. It is used to find the MAC address of the known IP. Hmm?
By using this protocol, we can map the IP address with MAC.
They map the IP address to the MAC address. How you can explain it is ARP is a layer 2 protocol. Okay. And it resolves MAC address for a known IP address. It resolves it. Doesn't maps it. Okay. So we can say that it is a layer 2 protocol that resolves MAC address for a known IP address. And actually it performs both kind of resolution. Okay. And vice versa. Does both the things. Okay. Resolve MAC address for a known IP address as well as resolves IP address for a known MAC address also. That was in the old times. Currently, that technology is not being used. Okay. So as of now, you can stick to this part only. Okay, because maybe the interviewer knows, maybe they don't know. So don't get it wrong. So better is you can stick to this thing. That resolves MAC address for a known IP address. That part, like for a MAC address, you can also fetch IP address. Okay, that we will explain in the types of ARP. Right. So if I talk about types of ARP, how many types? Hmm? How many?
Two types.
Two types. Okay. How many? Number? Three, five, six, five or six? Five. What are five types? Okay. One is your regular ARP, then not recursive, reverse ARP.
GR.
Then you have inverse ARP. Then you have proxy ARP. You have gracious ARP, or in short, GR. Okay. What is ARP? We already saw that what it does is MAC address for a known IP address. Correct? What about reverse of? Reverse of it, that means we can say that now, okay. What about inverse of? Used for, but this also does the same thing. This also does the same thing. Okay, your reverse ARP, it is not being used right now because it has been replaced by your protocols like DHCP and GoTP. Okay, this has been replaced because now we have DHCP, we don't require reverse ARP. Otherwise, in older times, we used to have reverse ARP servers where we used to have the entries that, okay, for this MAC address, this IP address is there. So whenever a device came up, it used to send a reverse ARP request that, okay, this is my MAC address. What is my IP address? And then the reverse ARP server used to reply with the IP address. But now we have DHCP, so we don't require the reverse ARP. Same thing, your inverse ARP used to do, but it was used in the frame relay networks. Okay. This was used in the frame relay networks. Okay. And your frame relay technology, it has been replaced by MPLS right now. So again, this is not being used. So as of now, currently in use, we have ARP, proxy ARP, and gracious ARP. And even proxy ARP very rarely being used. Okay, almost nowhere used. Okay, even if it is there, but it is disabled for security reasons. Okay, in the organizations, it is disabled for security reasons. Okay, but still in some cases, it is being used. So according to use case, we have ARP, proxy ARP, and GRP. Is that clear? Now, what is proxy ARP? Used when destination is in other network. Is it 100% right? Let's say my PC want to communicate with the Google server. Will there be any proxy ARP? Repeating my question, my PC wants to communicate with Google. Will there be a proxy ARP? Yes? Hmm? Yes? Might? Diplomatic answers. Is it going to be there or not? Yes? Sure? How many of you are sure? How confident? Hmm? Are you sure that there will be a proxy ARP? Hmm? No. If proxy ARP will be there, why? If not, why? Actually, your PC never generates a proxy. There is no proxy ARP in case of a PC. Okay. In case of a PC, you will never see a proxy ARP. Why? Think about it. Hmm? Okay. Practically, let's see this. Okay. Now, according to you, you tell me that, okay, I have a router. Okay. Then I have internet. And let's say I have a server, maybe Google or something. First of all, we will understand what is proxy ARP. Then I will answer this question. And all of you already know what is a proxy hop, right? This is our gateway. Consider the 0x0 interface here. And this one is the 0x1 interface. This is the internet. And let's say Google. Right? Consider the IP address as, okay. And here I have an IP address, something like this site. I have an IP address here. MAC address of my router's interface. Let's say this is M2, M3, and Google's MAC address, let's say M4. Then this is my PC1, has the IP address 10 and the MAC address M1. This is clear. Now from here, let's say I try to ping Google. Okay. From the PC, I'll try to do what? I'll try to ping google.com, or let's say simple 8.8.8. Right? And my PC maintains what? ARP cache. PC will maintain the ARP cache. In the ARP cache, what is the information? IP to MAC mapping. So kind of I'll have information about IP and MAC. This thing will be there. Same thing, ARP cache will be maintained by router also. This will be maintained by router, right? And router by default has entries in the ARP cache for its own IP addresses. Okay, so that means as of now, this router will have two entries. It will have one entry for 1.1, which is about M2, and it will have, let's say, sorry, 11, which is about M3. Okay. This is the case. Okay. Now, when I say ping, so my PC doesn't have anything in the ARP cache. And since I'm using ping, that means what kind of packet will be generated? ICMP will be generated. So let's generate an ICMP echo request. In the ICMP echo request, I'll have source IP, I'll have destination IP, I'll have source MAC, and I'll have destination MAC. Source IP will be 1.10. PC knows its own IP address, right? Then destination IP will be, I have given in the command 8.8.8.8. Source MAC address, PC knows its own MAC address, M1, right? Destination MAC address, it will check in the ARP cache. Do I have any entry? No, I don't have any entry, right? I don't have here any entry. So what will happen? Drop. PC never drops. PC will hold. Okay, there is a difference between PC and router. Router will drop the packet due to encapsulation failure. Router will drop the packet due to Encapsulation failure. PC will hold the packet. PC will not drop it. Clear? So PC has hold the packet, and since information is not there, so ARP will be generated. In the ARP request also, we will have source IP and destination IP, source MAC and destination MAC. Source IP will be same 1.10 PC1's IP. Destination IP we have mentioned 8.8.8.8. PC1 knows its own MAC address, and ARP request is a broadcast. So this will be all at right. Now this ARP request will go from PC to the router. What the router will do? Router will note down this MAC address. That okay, I have received a packet from where? 1.10. So 192.168. 1.10. From here I have received a packet. And what is this guy's MAC address? This guy's MAC address is M1. Right? Router made an entry in the ARP cache. Then router checks what is the destination IP. 8.8.8.8. Okay. But what kind of message this is? Can router forward a broadcast message from one interface to another interface? No. First case. Second case, ARP is a layer 2 protocol. Again, router cannot forward this from one interface to another interface. So if router will not forward it on the other side, will you ever get the MAC address of Google? No. So that means for providing communication, router will facilitate communication. Router will respond on behalf of Google. Router will respond on behalf of Google. So what router will do here? Router will send its own MAC address. Okay. So router will send this reply. So this reply is what basically because PC was generating a normal app only. It was router who responded as a proxy, right? So router will say source IP, destination IP, source MAC and destination MAC. Router will say my IP address is 8.8.8.8 and the destination will be 1.10. Okay. Then after source MAC address, router will give M2 and destination MAC address. Router has already noted that, okay, what is the MAC address for 1.10 in the ARP cache? M1. M1. This reply will come to the from router to PC1 and then PC1 will make an entry here. Right? So PC1 will make an entry that, okay, I have received a reply from 8.8.8.8 and MAC address is yes or no? Understood how proxy app works? Now, according to this concept, I should have an entry for 8.8.8.8 with the MAC address of my router in my ARP cache if there is a proxy ARP in case of PC. Right now, we have understood how proxy ARP work and how router is responding with the MAC address. But again, before some time, I just told you that in case of PC, there is no proxy ARP. Right? Because if there is a proxy ARP, technically, I should have an entry for whatever the IP address I'm communicating on the internet. Right? So I should have an entry of the 8.8.8.8 with the MAC address. Correct? Okay. Let's check it. Command prompt. I'll open. This is my command prompt. Okay. And I'll show you ARP cache. ARP-A. Okay. You can take a look. I have multicast addresses. I have private addresses. I don't have 8.8.8.8. Agree? None of the interface has it. See here, 172 to 128, 192, 168.10. Then I have 192, 168, 190. All the private IP addresses, multicast, and then broadcast. That's it. right? Now let me try to communicate. I'll say ping 8.8.8.8, right? And according to our calculation just now we did, right? According to our packet flow, I should get a MAC address entry for 8.8. I'm having communication. Successful replies are coming from 8.8. But if you take a look, still do I have an entry for 8.8 anywhere? No, I don't have. Because in case of PC, there is no proxy app. Why there is no proxy app in case of PC? The reason is when ARP request is being generated, right? When my PC first generates ICMP, right? First my PC generates ICMP. Destination MAC is not there. Destination MAC is not there. So my PC has to generate what? ARP request. So while generating the ARP request, my PC will check that what is the destination IP here? 8.8. Is it in my same network? No. And if I have to communicate with different network, what do I need? I need a default gateway. I need default gateway. So this ARP will never be generated for the destination. This ARP will never be generated for destination. Instead, it will be generated for your default gateway. This will be generated for your default gateway. And since this is getting generated for default gateway, this request will reach to the router. And when router will respond, this time, router doesn't have to respond on behalf of anybody. Okay. Router is responding on behalf of himself only. So when you are not responding on behalf of anybody else, is it proxy? No, it's not proxy. This is the ARP reply router will send out to the PC. And when PC will make an entry, you will have an entry for your default gateway. This entry will be there for your default gateway. This is the reason that doesn't matter how many websites you're visiting every day, your ARP cache doesn't get filled up. Why? Because you might be visiting hundreds and thousands of websites every day. And if there is a proxy ARP router is using, in that case, what will happen? Your ARP cache will get filled up. Memory consumption will be there. Extra traffic will be there. Because router has to generate, your PC has to generate an ARP for every single website. That will cause latency and extra traffic in your network. That is the reason. And imagine in organizations where thousands of systems are there, generating thousands of ARP for every single website. What is the amount of broadcast traffic will be there in your network? Understood? For this reason, your PC never generates a ARP for the destination. And there is no proxy ARP in case of a PC. Clear? Now let's see this thing practically. Okay. Online people, this thing is clear.
Yes, sir.
And according to real scenario only, I'll show you. Okay. Oh, let's I'll take a PC. I'll take a router. Which will be acting as my gateway. And I'll take internet. Okay. Z0 by 0 connected to my LAN side and Z0 by 1 connected to my internet side. Okay. This is my gateway. So on this side, I will take an IP address from the DHCP only. Okay. Like generally also your ISP provides you the IP addresses, right? Okay. And then here I will use a private network, this side. So let's say, for example, on PC, I will use the IP 10.1.1.10. Okay. Here I'll use the IP 10.1.1.10. And my gateway IP address, I'll use, let's say, for example, 10.1.1.1. Okay. The network that I'm using here is 10.1.1.0/20. This is clear. And I'll configure NAT on this router because in real scenarios also you use what? Translation. That my internal network will get translated to my outside interface IP, right? Okay. So first of all, let's take access of the Windows. Well, yes. Or should I increase the size? Now, okay. So as of now, I'm not having any IP address here. You can see IP config and I'm getting an APIPA IP address. Okay. So I'll just go and configure an IP address here. So here I'll configure 10.1.1.10, 255.255.255.0, and gateway will be 10.1.1.1. And DNS, let's say I'll use 8.8.8. Clear? Okay. So you can check the IP address again, what I have configured. Address. This is the IP configuration I have done. Clear? Now, Let's take access of the router. I'll say no. This is not participable. So global configuration mode, host name, I'll change it to gateway. Okay. So right now, if I check do show IP interface brief, you can see interface gig 0/0 IP address unassigned, v0/1 also unassigned. So my LAN side interface is z0/0. So here we will assign 10.1.1.1 and this side we will take IP address from DHCP, right? So I'll say interface gig 0/0 IP address 10.1.1.1 255.255.255.0. Done. Then I'll say no shutdown. This is clear. Exit. Okay. Now interface gig 0/1. How do I take IP address from DHCP? DHCP full. On a router interface, if I need to take IP address from DHCP, how? No idea. Command is IP address DHCP and then say no shutdown. Once this interface will come up, it will send DHCP discover messages and it will try to get an IP address. You see, I received an IP address 172.16.1.109. This is my IP address here, okay? IP address is 1.109. Okay. And to configure default route, because I need internet connectivity, right? So I'll configure a default route, and for default route, I need my gateway IP also. So my gateway is 1.1. So I will give a default route towards 1.1. Okay. So I'll say IP route and 172.16.1.1. Let me test the connectivity. Do ping 16.1.1. I have connectivity with my gateway. If I say do ping and 8.8.8.8, you can see I have internet connectivity also. Correct? Okay. Now I'll configure NAT so that this PC, Windows PC, can also get internet. Okay, right now this Windows PC is not having internet, you can see here. No internet connection. So I'll configure NAT here. Okay. So to configure NAT, how do you configure NAT in the router? First of all, you will give inside and outside interfaces. Okay. So your LAN interface is the inside interface, which is Z0/0. So this is inside, this one is outside. So you'll say interface gig 0/0 IP NAT inside. Interface gig 0/1 wait for it. Router CPU is busy. Okay. So interface gig 0/1 IP NAT out. Done. Then we will configure an ACL to select the network that you want to translate. So I'll say access list 1 permit the network 10.110.0.0.0.25, right? Then we will say IP NAT inside source. Okay. List number 1 I want to translate into the interface. Okay. And what is my interface number? G0/1, and I want to overload it. That means basically port address translation I'm configuring here. Done. Let's check the internet connectivity in the PC. If I try, you can see the yellow mark has been removed. And if I say ping 8.8.8.8, I have the connectivity. I got the internet connectivity. Now, if I check the ARP cache, if I say show ARP, sorry, ARP-A, so you will see right now I just pinged with 8.8. But do I have an entry here? No, right? There is no entry. If I will ping any other IP also, okay, now I'll capture the packets here. So what I'll do, I'll capture the packets on interface Z0/0 of the router so that we can see what packets are coming from the PC. Do you see any packets here right now? No. Let's try to ping. Not from here, from the PC. Okay. And first of all, if I check ARP cache ARP-A, so ARP cache is already built up. Okay, I'll clear the ARP cache. So ARP cache has been deleted. Okay. Now if I try to ping, if I'll say, okay, already they have communicated. See, Windows in the backend already communicated. So they already have the ARP cache again. See? Okay. But still, it will never generate an ARP. Okay, if I'll try to ping also. Let's say right now I'll try to ping. So I'll say anything that has an IP address 8.8.8.8. Only those packets I want to see. Packets which are containing the IP address 8.8.8.8. These are the packets. And these are packets related to DNS only. And let me restart the capture also. Okay. Let me restart the capture. No, yes. Okay, and I'm just filtering all the packets which are having the IP address 8.8 because I want to show you that when I ping 8.8, there will be no ARP generated. Okay. Now take a look. I'll say, as of now, if you take a look at my ARP cache, only these entries are there. I'll say ping 8.8.8.8. Now you take a look. I directly have ICMP. There is no ARP. Why? Because whenever my PC is trying to send an ICMP here, it is using the MAC address of my gateway, which is 10.1.1.1. What is the MAC address? 020000. Take a look here. What is the destination MAC address here? Is it same with my gateway MAC address? So that is the reason that PC will never have a proxy ARP. PC is never going to have a proxy. Clear now? So in case of PC, you are never going to see a proxy ARP. But yes, if you have a router, in case of router, you can see the proxy. There you will clearly be able to see the proxy. Guys, this is clear online people?
Yes.
Now, in case of router, if you want to see, let me use packet. So that thing you can see in the packet tracer also. Now let's go like this. So as of now, I'll consider this is again our gateway. And this is, let's say, R1. This is PCB. That means this time I'll disable the routing features on the router. Okay, so that it will behave like a host only. So again, here I'll use the IP address 10.1.1.10. This side I'll use the IP address 10.1.1.1. This side we will use 11.1.1.1. In this side we will use 11.1.1.2 or 20. So let's quickly configure all this. Enable configuration terminal, host name, PC1. And to make it like a PC, I'll say no IP. Okay, then interface gig 0/0 IP address, and I'll say 10.1.1.10.255.255.255.0 and no shutdown. Now, this router or the PC host, it will also require a default gateway for communication. So I'll give it a default gateway. I'll say IP default gateway, and the default gateway IP address is 10.1.1.1. This is the configuration done on this side. Similar configuration for this one. We configure the IP 10.1.1.10. Enable configuration terminal, host name PC2, interface gig 0/0, IP address 11.1.1.20, no shutdown, no IP routing. Then configure the default gateway also. IP default gateway 11.1. Done. Now, no enable configuration terminal, host name, gateway, interface gig 0/0, IP address 10.1.1.255.255.255.0, no shutdown, 3.0/1 is 11.1.1.1. Okay. All the configuration is done. Now, to simplify our understanding, I will change the MAC addresses also. So that just by looking at the MAC address, we can know that, okay, for which device the MAC address is. So PC1, we will make all zeros and 1. PC2, all zeros and 2. Okay, and here we will use all zeros A, all zeros B. Okay. So here, interface Z0/0. Okay, on the gateway, I'll use the MAC address. Sorry. Okay. This is the MAC address. And Z0/1, I'll use all zeros and Okay. So we will understand if A, that means MAC address of this interface. If B, that means MAC address of this interface. Same way, if 1, that means PC1. If 2, that means PC2, right?
PC2.
Yeah. So let's say interface big 0/0 MAC address. Okay. And for PC2, zero MAC address. Done. Now see, I'll directly start capturing the packets. We just need ICMP and ARP. Okay. Currently, if you check the ARP cache of these PCs, so they will have their own entries only. See, show ARP. They have their own entry only, all zeros and one, right? PC1 has its own entry only. What about PC2? Show own entry only.
One entry. Yeah.
And I mean gateway will also have its own entry only. Correct? Okay. Now let's go to the PC1 and try to ping. So I'll say ping 111120. Okay. Definitely two messages will be generated. One will be your ICMP. Another one will be ARP. Right? And this time, since this is a router, so when this ARP is getting generated, if you take a look, what is the destination IP in the ARP? The destination IP is the actual destination only, not the gateway. And this is where your proxy ARP will be there. Okay. Now what will happen? This first packet, ICMP, it will drop due to encapsulation failure because router does not hold the packet. Router will drop the packet. PC holds it, router drops it. Okay. So this first packet will be dropped and your ARP will travel to the router, right? As soon as it travels to the gateway, now what gateway will do? See here. Earlier when I checked the ARP cache, there was only 2 entries for self. Now there will be 1 entry for 10.11.10 also. So if I say show ARP, take a look. I got an entry for 10.11.10, right? And what this router will do now, on behalf of this guy, because router will see that, okay, the destination is in a different network. And this is a broadcast message, I cannot forward it to a different network. And this is a layer 2 protocol packet, I cannot forward it again, right? So if I open it, do you see it has layer 1 and layer 2 information only. There is no layer 3, correct? So the incoming packet has source MAC address as whose MAC address? PC1. Destination is source IP as PC1 IP. Destination IP as PC2 IP. The outgoing packet from the router. This is the incoming packet. This is the outgoing packet. If you take a look here, what is the source MAC address? Router's MAC address. Destination MAC address. PC1's MAC address.
Interface. Yeah.
Source IP, PC2's IP. And destination IP, PC1. Now, why this is happening? Okay, see here. The ARP frame is a request. The ARP request target IP does not match the receiving port IP. The ARP packet's target IP, that means destination IP, does not match the receiving port's IP. That means router sees that, okay, this is an ARP, but this is not matching my own IP. This is some other IP. So what router will do? Router will check whether or not proxy ARP is enabled. So router sees that, okay, proxy ARP is enabled on this port. So what I'll do? I'll respond on behalf of that IP. Okay. So the ARP process will check the routing table whether the requested IP is reachable or not. That means the router is able to reach this IP or not. If reachability is not there, nothing. Okay. The requested IP is in the routing table. That means reachable. So router will do what? Router ARP process will update the ARP table with the received information. That means this IP address and this MAC address, and then router will reply with its own MAC address. Clear? So because this is a router generating the ARP for the destination, that is the reason proxy ARP is there. If it is a PC, it will generate an ARP only for gateway IP, not for the destination IP. Okay. So right now you see who is the source here? 11.11.20. But where is the packet? Is it with the 11.11.20 or with the router only? With the router only. So this packet will never reach here. Okay. And even router doesn't have the MAC address for this guy. So as soon as router will reply to the PC1, PC1 will send the ICMP and then router will drop it. Why? Because router doesn't have the MAC address of this guy. So router will drop that ICMP packet and then router will generate a ARP here. Okay. See here. This reply will come here. PC will send what? The ICMP, right? And this is the ICMP, right? First packet was dropped. This is the second ICMP. Okay, you can take a look here. The first ICMP is a dot, right? Now, ICMP came here, router will drop it because I don't have the MAC address. MAC address for this IP address. I don't know how to reach this guy. So what? Router will also generate a ARP. Now this is the router generating ARP for this IP. So this is normal ARP, normal response. Okay. So here we don't have anything to check. This is ARP request, ARP response. So overall, as of now, 2 ICMP packets got dropped. One at PC1, second one at gateway. Right? Now third ICMP. This is our third ICMP packet. Now this guy has a MAC address of the gateway. This guy has the MAC address of. So that means this time our ICMP will definitely reach PC2. Reached. But this guy will say, okay, I don't have the MAC address for 10.11.10 because I need to reply also, right? Now again, this guy will generate an ARP. And again, for ARP will be what? For the destination 10.11.10 because this is a router. And again, this router will respond as a proxy. This router will respond as a proxy. And here our third ICMP packet also got dropped, right? So this is ARP request, and then response will be what? Proxy ARP reply. Okay, you can see router responding on behalf of 10.11.10 with the MAC address all B. Correct? So this response will come here, and this guy will also have the MAC address for gateway. Now what? Our 3 ICMP packets got dropped. You can see. Okay, in some time you will see. So it should be updated now. Yeah, you can see 3 got dropped. This is number 4. So now everybody has the MAC addresses. So now you'll get a response. ARP request, sorry, ICMP echo request, ICMP echo reply. This one is success, exclamation. And same way, number 5 will also be success. So out of 100, 40% is your success. And now everybody has the MAC addresses. Second time you'll ping 100%. This is clear. Now we can ping. And we have 100%. Clear? Any doubts? Online people?
No.
Okay. So I believe now proxy ARP is clear. So whenever you explain proxy ARP, make sure to understand and to mention that for PC, there is no proxy ARP. Okay. Okay. Then after proxy ARP, we have another ARP which is ZARP. What is ZARP? Why this is used? Hmm? Provide duplication. How duplication is avoided? But how? It is me, I can statically assign. Then what kind of packet? How ZR checks duplication? Broadcasting the packets to all the devices. Okay. When a GRP is generated? When? Sorry. When DHCP assign IP. Let's say I'm assigning the IP statically. Will there be a GRP? Hmm? Is it? My question is, if I'm DHCP, we know that okay, the offer message will come, then the client will check for the duplication using a GR. But what about static IP? Everybody knows DHCP theory. What about static? If I'm statically assigning an IP address, will there be a GR? Yes. Sure. How many of you think there will be a GR? Because statically, I'm manually assigning IP. One, two. Hmm? There will be. Yes, there will be. Okay. Even you are assigning IP address statically or it is via DHCP, in every case, there will be a GR. Okay, what else? Where else have you seen the GR concept? Where else GR will be generated? Change the IP address. Okay, that is done. Any other concept like DHCP, you have seen GR, you have studied it, GR. Statically, we know that, okay, even if you statically assign IP address, GR will be generated. Where else? Hmm? Because you have studied this thing, that's why I'm asking. HSRP, you have studied active standby concept. So whenever your active goes down, standby will take up the active role. That time also GR will be generated. Otherwise, how your clients will know that, okay, now where to send the packets? How your switch will come to know that, okay, if packet is coming for this MAC address, how to forward it? Okay. So whenever your active standby role changes, that time also GRP is generated. Yeah. Okay. So let's take an example of two PCs. PC3 and PC4. And directly I'll go to here, the PC, and I'll try to assign an IP address. Now here, if I assign, let's say for example, 10113, any problem? No. If I go here and if I assign 10114, any problem? No, because these are unique IPs. no problem. But if I go here on the PC port and if I try to assign 10113, what it says, this address is already being used in network. How does it come to know that this is being used in the network? With the help of GR. So let's see. I'll go to simulation mode. This time we don't require ICMP also. I'll go here and try to assign again. 10113. Okay. As soon as I do this, you see one message has been generated. What kind of message? ARP. And inside the ARP, what kind of ARP it is? This is gracious ARP request. So how does your PC checks that okay, same IP is there in the network or not? Let's say my name is Ajay and I want to check that okay, any other person is there with the name Ajay or not. How can I know it? I'll just call out the name. Everybody will listen it. If somebody is there with the name, they will respond. And if somebody respond, I will get to know that okay, the person is there. And if nobody respond, nobody is there. So that is the thing. That okay, source IP is this, but destination is also the same. Destination is also the same. And this packet is a broadcast. That means everybody will process the packet. In my network, everybody will process this packet. So this is how it gets to know that, okay, my destination is what? 10113. So what this guy will do? When this guy will receive, this guy will see that, okay, same IP as a source. I will not accept it. I'll drop this packet. And then this guy will also send a GR. This guy will also send a GR for the same source and same IP to notify what? That this is already being used. So if this guy will receive an IP from the 10113, this guy will come to know that, okay, somebody is already there and using the address. That means I cannot use it. So this guy will receive it and this guy will say address is already used in the. This is in the packet tracer. Now, how does it look like in the real scenarios? Let's say actual real Windows PCs. Let's see. So delete this one. Oh, not delete. And same IP I'll try to assign on the second PC also. Okay. Let's name it PC2. And this one is PC2. And this one is PC1. I'll directly connect. This is PC1. And this side we have PC2. Okay, these are both PCs, PC1 and PC2. So I believe we had already assigned IP in this one. So you can see 10.1.10 IP is already there on the PC1. Okay. And also let me start capturing the packets. Okay. And we will capture. Okay, on the ARP packets we will see. PC1, PC2. And as of now, if I take a look here, let me change the font size. If I check IP config, so Apipa is using, let's try to assign now. Same IP I will try to assign 10.1.1.10, 255, 255, 255, 0, 10.1.1.1. Okay, I'll say okay. Close. Any notification so far? No. And has it taken the IP address? Do you see? The IP address was not accepted. Why? Duplication. So what is the MAC address? Let's say, for example, here for PC2, MAC address if I check. So you can use the get MAC command that will give you the MAC address. So MAC address for PC2 is 020000. Okay. So these are all the packets you see. And here it's trying to get an IP address using Apipa. We need to check the first message from here. Standard IP address 00. Oh, Windows continuously keep on generating, so we have to find out the packet. No. Let's try to search for this is for target IP address 10.1.1.1. Opcode is one. That is the request. Okay, let me start the capture again. I think now they are not doing it. Okay, then I'll disable and enable that up. Okay. So I'll disable and enable the adapter now. Disable. Now we'll look at the first packet that is coming from 02. Disable it one more time. It's a bit tricky to see here. This is first up, and this is a broadcast. Here it's not showing the source IP as 10.1.1.10. Yeah, here now you can see. This is the GR. Okay, not for that IP, but once it took APIPA IP, you can see. Source IP and destination IP will be same. Okay, source IP and destination IP will be same here because it has taken APIPA, so they will generate a GR. So any IP, whether it is being taken automatically APIPA or statically assigned, it will always generate a GR. And even though if I go and try to assign some other IP also, okay, just take a look. What I'll try to do is I'll try to assign some other IP also. It will generate a GF again. Okay. Let's say I'll give here 20. Okay. So even though I'm assigning this IP statically, a GRP will be generated. Okay. See here. This is the GR. For 10.1.1, 20 volts. So whether DHCP statically or APIPA. Any sort of address assignment, GRP will be generated. So one reason for GRP is what? To check the duplication. Second is what? To announce the IP to MAC mapping, which happens in case of your HSRP protocol. The second device that is coming up from standby to active, that announces that okay, I'll be using this IP now. So IP to MAC mapping is also announced with the help of GR. Clear? And then GRP is also used in cybersecurity to perform man in the middle kind of attacks. That means to sniff the information. Clear? Online people?
Yes.
So this is it for the day. Okay. Next topic.
Today, like you have shown these things in EVNG, I suppose.
Mhm.
So, will there be should we install EVNG and start practicing in this manner, or will you give a demo of like how to do all this stuff?
Okay, you mean to say like how to set up EVNG?
Yeah, yeah.
For
Or
EV,
how to?
yeah, for EVNG, I'll drop the number of the lab trainers in the group so you guys can communicate with them. They will help you with the EVNG installation. Okay.
Okay.
Yeah. So if you face problem in the EVNG installation or image uploading, they will help you with it.
The lab trainers will help, right?
Yeah, exactly.
Okay.
Yeah, they will provide you with the images and everything. Okay.
Okay.
And for tomorrow, the topic is DHCP protocol. Okay. So make sure to study DHCP a bit deeper. And all 8 messages of DHCP also you're supposed to study. That what are the 8 messages and why each message is used. Yeah.
Okay. And from now onwards, we'll be doing the lab in EVNG.
Yeah, only EVNG. I'll be preferring EVNG only because even your CCI exams are taking place in the EVNG. Okay.
Okay. Okay. So the lab trainers numbers and all, will we get it in WhatsApp and all
Correct. In the WhatsApp group.
in the WhatsApp group? So we didn't receive any mail yet. So have you sent?
You will receive it today. Okay. No
Okay.
has received because I didn't get the verification. Today you guys will be receiving it.
Fine.
Okay.
Fine.
So everybody
Oh.
will get the access today only.
Oh.
Okay, guys, then prepare DHCP. I'll see you guys tomorrow. Have a good day. Bye.
All right.